Alright students, so today we are going to find the centroid of a triangle, and to find the centroid we need the three medians. And a median basically is when you have a segment from one vertex to the opposite side's midpoint. So to find that median, we would have to first find this midpoint here. And to do that, you take your compass and place it on one of these two vertices and adjust it so it's past the midpoint. You make an arc on top, on the bottom, from both vertices, like so. And you actually don't draw a segment between these two. You just lined up your ruler to determine this midpoint. Once you find the midpoint, then you connect a segment from this vertex to this midpoint. And you do the same process for the other two sides. You find that midpoint, and then you connect a segment from the opposite vertex to that point, and that process is repeated for this segment over here. Find the midpoint and then connect a segment from this vertex to that point right there. And if you do this right, you should have a point of concurrency. So that's where two or more lines meet. This point here, it's called the centroid. And let's just give these points some names. Let's call this point here P. So AP, so from A to P, this section here will equal 2/3 of the entire median. So 2/3 of this entire median, always. So we call that AF. Alright, and that's the case for any median. If we look at this side here, CP is equal to 2/3 of CE, as well as this one here, BP equals 2/3 of BD. Alright, so this is called the centroid, and in order to find the centroid, you must come up with the three medians. Alright, so this is one point of concurrency. Then we have another one, and I'm going to erase all this. I'm going to erase all this right here and draw another triangle. Let's call this triangle ABC, and we are going to find the orthocenter. To find the orthocenter, I first need to determine where the three altitudes are. Alright, an altitude is basically just the height. And in this triangle we have three different altitudes. So to do that, place the point of your compass on A and adjust it so it passes CB. Just a little bit beyond CB, you make an arc like so. And then you take your compass and you place it on one of these two points of intersection. You draw an arc below from both points, and the point where these two arcs intersect you're going to draw an arc from vertex A to that point. And if you do that right, this is an altitude. Okay? There's 3 different altitudes. You will do it to this vertex as well. Extend your compass so it passes, or it goes beyond AB. You draw an arc, same idea. 2 points of intersection. Place the point of your compass on one of these points. Make an arc to the right from both points. And then connect a segment from vertex C that passes through that point. And if you do that correct, this is also another altitude. So if you notice we have a point of concurrency. That's where all 3 lines meet, which means the last altitude will go through this point, and this will be 90 degrees as well. We call this the orthocenter. The orthocenter, and to find the orthocenter we need the 3 altitudes. The orthocenter, just like the circumcenter, could be inside the triangle if it's acute. It can be on the actual triangle, on the line or a segment if it's a right triangle, and outside of the angle if it's an obtuse triangle. So that was the orthocenter, and right before that we had the centroid. I hope this helps. Please let me know if you have any questions.